Hello grade 10 students. Today I am here to teach you chapter 17 in your textbook that's called Parallelograms II. In chapter 16 we discussed about 6 theorems and we'll revise all the 6 theorems in this chapter as well, and the exercises and the examples in chapter 16 was related to 2 theorems. We'll see what are those theorems. Chapter 16, theorem number 1. In a parallelogram, opposite sides are equal, opposite angles are equal, and the area of the parallelogram is bisected by each diagonal. What it means? When it's a parallelogram, that means opposite sides are parallel. We found out opposite sides are equal. Opposite angles are equal. This angle is equal to this angle. This one is equal to this one. What's the other one? Third one, the area of the parallelogram is bisected by each diagonal. That means if it's a parallelogram, diagonal is this one, the area of these two triangles are equal. It's okay for the other side as well. Then the theorem number 2, in a parallelogram the diagonals bisect each other. What it means? Opposite sides are parallel in a parallelogram. When you draw two diagonals, those are bisected each other. That means this distance is equal to this one. This length is equal to this one. So we discussed these 2 theorems in chapter 16. And in chapter 17, we need to discuss 4 more theorems. But I explained those in chapter 16. We'll see what are those. Theorem number 3. If the opposite sides of a quadrilateral are equal, then it is a parallelogram. So that means it's a quadrilateral and opposite sides are equal. It's given this side is equal to this one side is equal to this one. Opposite sides are equal, then we can say this is a parallelogram. The other one, if the opposite angles of a quadrilateral, any quadrilateral, opposite angles are equal, then we can say it's a parallelogram. Theorem number 3, if the diagonals of a quadrilateral bisect each other. If you take the diagonals and here if this length is equal to this one, this length is equal to this one, then we can say it's a parallelogram. All these 3 are converse theorems of theorem number 1 and 2. And the special theorem we discussed, if it's a quadrilateral and a pair of opposite sides is equal and parallel. This side is parallel and as well as equal. Only one side. One pair is parallel and equal. Then it's also a parallelogram. So we'll discuss these 4 theorems in chapter 17. We'll take these examples and try to apply those theorems in these examples. ABCD is a parallelogram because we can see opposite sides are parallel. Find AD and DC. What's the theorem? Which theorem we can apply? If it's a parallelogram, opposite sides are equal. So if this side is 10 centimeters, what's the CD side or DC side? DC side, we can straight away write down that's 10 centimeters. What's AD? AD is the opposite side to BC. What's the length? 7 centimeters. Opposite sides are equal in a parallelogram. What's the next one? PQR is a parallelogram and the P angle is given 70. Find the other angles. Now, use the other theorem. Opposite angles of a parallelogram are equal. If this is 70, this is also 70. So, we can write the R angle is 70 degrees. Opposite angles are equal. Then, how can we find out Q? We need to use allied angles. If these two are parallel, allied angles add up to 180. So, we can find out Q as 180 minus 70, that's 110. We'll write down the reason. Allied angles add up to 180. This one, what's the reason? Opposite angles of a parallelogram. Then again, S, what's S value? These two are opposite angles. So, S is also same as Q value. So, 110 degrees. Now, look at the third example. AO is 8 centimeters. This distance is given 8 centimeters and OB is 5 centimeters. And this is a parallelogram. Opposite sides are parallel. Find CO and OD. What's the CO value? CO is same as AO. Diagonals bisect each other in a parallelogram. We can write 8 centimeters for CO and what is OD? OD is 5 centimeters. What's the reason? We can say diagonals bisect each other. Now we'll look at this example. ABCD is a parallelogram. You are asked to find out X, Y, Z. What can you say about these two sides, AB and CD? AB and CD are opposite sides of a parallelogram. Opposite sides are equal. We can write 3x minus 1 is equal to 2 times x plus 1. What's the reason? Opposite sides are equal. Then solve for x. Expand brackets and take all x terms to one side. When you take 2x to this side, you get 3x minus 2x. And take minus 1 to the other side, 2 plus 1. So 3x minus 2x is x. So x equals 3. How can we find out y? Y is here. We know that if this is 102, this is also 102. Opposite angles are equal. Then you can think about ADC triangle and find out the y value. Y is the exterior angles to these opposite interior angles. So what's the theorem there? You can write down y is equal to the sum of opposite interior angles. So 152 degrees. Reason is exterior angle is y. Z value is here. How can we find out? Look at this one. These two lines are parallel. So this is equal to this one and this one is equal to this angle because alternate angles. So we can say this is 50. And also using this triangle, or what's the other method we can use? Can you see these two are allied angles? Allied angles add up to 180. I can write 50 plus z value plus 102 is equal to 180. The reason is allied angles add up to 180. Now find z. 152 is equal to 180. So z value is 180 minus 152. What's the answer? You get 8, 1 remaining 2. So 28 degrees for the z value. So I'll write down here z is equal to 28 degrees. Now look at this example. You are asked to find out this angle. That angle is x. Look at carefully. ABCD is a parallelogram. PQRS is also a parallelogram because opposite sides are parallel. If this is parallel, this angle is equal to this angle. Opposite angles are equal. This one is equal to this angle. Now what can we say about this angle? This angle is allied angle to this one. 180. C and B add up to 180. So what's the C value? C angle is 180 minus 120. You get 60 degrees. So this is 60, this is 70. What's x? The sum of angles in a triangle is 180. 70 plus 60 is 180. Sum of angles in a triangle. X plus 100. 6 and 7 becomes 13. 130 is 180. So the x value is 180 minus 130. That's 50 degrees. So we can find x as 50 degrees. Look at example 1 in your textbook. It's given T is the midpoint of the side BC of the triangle ABC. We'll try to sketch the diagram. There's ABC triangle. ABC triangle. The midpoint of BC is T. I can take this one. So midpoint means this length is equal to this one. The straight line drawn through C parallel to AB. Parallel to AB means this line is parallel to this one. Meets AT produced. AT produced. So that means this way. When you join AT, AT produced at D. So this is the D value. Prove that ABCD is a parallelogram. ABCD is a parallelogram. So they are asking, show that this one, I'll connect this one, ABCD is a parallelogram. To show that it's a parallelogram, we can use any theorem. If we can show that this length is equal to this one, or this side is equal to this one, we can show this is a parallelogram. Which one is the easiest? We'll take these two triangles, ABT, this triangle, and CDT triangle. What can you say about those triangles? BT is equal to TC. That's given because it's the midpoint. And also these two lines are parallel. AB is parallel to CD. Because of that, this angle is equal to this angle. Alternate angles are equal. BAT angle is equal to TDC angle because those are alternate angles. And also, what can you say about this angle? This is equal to this one. Vertically opposite angles. ATB angle is equal to CTD angle. Vertically opposite angles. Then what can you say about these two triangles? These two are congruent. ABT triangle is congruent to CDT triangle. What's the situation? Angle, angle and a side. If these two are congruent, opposite to this angle, the opposite to this angle is this length. This is equal to AB is equal to CD. Corresponding elements are equal. Now what can we say about the ABCD quadrilateral? We can say AB is equal to CD as well as AB is parallel to CD. What's this theorem? Theorem number 6. A pair of sides equal and parallel, then the quadrilateral is a parallelogram. Therefore, ABDC is a parallelogram. You can write this is because of theorem number 6 we discussed before. Look at exercise 17.1. From the following quadrilaterals, select the ones which can be concluded to be parallelograms based on the given information. Look at this one. These two sides are equal, but not given those are parallel. Other two sides are parallel. Can we say it's a parallelogram? No, we can't say this is a parallelogram because these ones are parallel and the other two sides are equal. B, opposite sides are equal. Opposite sides are equal means this is a parallelogram. Part C. This angle is not the same as this. Opposite angles are not equal. So this is not a parallelogram. D. Opposite sides are equal. That means it's a parallelogram. Part E. Opposite sides, a pair of opposite sides equal and not mention anything. So we can't say this is a parallelogram. This one, diagonals bisect each other. According to theorem, it's a parallelogram. G. These two sides are parallel and the other two sides are equal. We can't say this is a parallelogram. H. Opposite sides are not equal. Therefore, it's not a parallelogram. Opposite angles are not equal, not a parallelogram. Diagonals bisect each other. This is a parallelogram. A pair of sides parallel and equal. It's a parallelogram. Diagonals are not bisected each other. It's not a parallelogram. Here, opposite angles are equal. It's a parallelogram. Here, this is 60, this is 60. We need to find out this angle to identify whether opposite angles are equal. 120 and 60, 180. 180 plus 60, you get 240. So, what's the other angle? 360 minus 240. 120. Then we can say opposite angles are equal. Then it's a parallelogram. We'll try to find out this angle. 100, 100, 200, 275. So, 360 minus 275. 85 is this angle. Now we see opposite angles are not equal. So, this is not a parallelogram. Look at this one. Opposite sides, a pair of opposite sides equal. But this angle is not equal to this one. So, alternate angles are not equal means this side is not parallel to this side. So, we can't say this is a parallelogram. This one. This is 110 and 60. When you add up together, you get 170. Allied angles should be equal to 180. So, this is 170. That's not a parallelogram. This one, 180. So, when you add allied angles, 100 plus 80, 180 means this side is parallel to this side and also it's given as equal. This is a parallelogram. This one, opposite side, a pair of opposite side equal. What can you say about the other one? Now, if this is 55, this is 55, alternate angles are equal means this side is parallel. Can we find out the other angle? No evidence to find out the other angle. A pair of these two sides equal, but the other two sides are parallel. This is not a parallelogram. Last one. What can we say? This is not a one full diagonal. This is 48 and we can't find out the other angles. This is 48, then you can find out this angle, 90 minus 48. 42, and this angle 90 minus 50, 40. Here, alternate angles are not equal, 40 and 40. So, this is not a parallelogram. Question number 2. The midpoint of the side DC of the parallelogram ABCD in the figure is P. AD and BP produced meet at E. This point, prove that BCP triangle and DPE triangles are congruent. Prove that the quadrilateral BCED is a parallelogram. So, we'll first find out BCP. This triangle and DPE triangles are congruent. In these two triangles, we see DP is equal to PC because of the midpoint. It's given. And these two sides are parallel. Then what can you say about this angle and this angle? These two are equal. DEP angle is equal to PBC angle, alternate angles are equal. And also this angle is equal to this angle, DPE. DPE angle is equal to BPC. Vertically opposite angles. Vertically opposite angles are equal. What can we say about the triangles? BCP triangle is congruent to DPE triangle. What's the situation? Angle, angle, and a side. So that's the first part. Second part, you are asked to show that BCED, this one, BCED means, I'll take another color, green. You are asked to show that this is a parallelogram. What can you say about that? We know these two sides are parallel. It's given. If we can show those two sides are equal, then according to theorem, a pair of sides is parallel and equal, then it's a parallelogram. How can we say this side is equal to this side? Because of these two congruent triangles, we can say DE side is equal to BC side, opposite to this angle, and this is opposite to the other angle. Corresponding elements. Corresponding elements of the congruent triangles. So these two sides are equal, as well as DE is parallel to BC side. A pair of side equal and parallel, we can straight away write down BCED. BCED is a parallelogram. Question number 3. AB and CD are two diameters of the circle of center O in the given figure. Prove that AC, B and D are the vertices of a parallelogram. So you are asked to show AC, B, D is a parallelogram. But when you look at the diagram, this is about a circle. We can write OD is equal to OC, as well as AO is equal to OB, as well as equal to OD and OC. All these lengths are equal. Radius of circle. So what can you say about the quadrilateral ACBD? It's a parallelogram. Therefore, we can say ACBD is a parallelogram What's the reason? Diagonals are bisected each other. So according to the converse theorem, if the diagonals bisect each other, then that quadrilateral is a parallelogram. Question number 4. In the parallelogram ABCD, in the figure, the perpendiculars drawn from the points D and B to the diagonal AC meet AC at the points X and Y respectively. Prove that AXD triangle is congruent to BYC. These two triangles. We'll take AXD triangle and BYC triangle. It says diagonals meet at this point. When you take this angle, this is 90, so this is also 90. This is given 90. We can write down DXA angle, CYB angle, and it's 90 degrees given. These two lines are parallel. AD and BC lines are parallel. We can say this angle is equal to this one. Alternate angles are equal. DAX angle is equal to BCY angle. Alternate angles. Also, ABCD is a parallelogram. Opposite sides are equal. This length is equal to this one. So, AD is equal to BC. Opposite sides of ABCD parallelogram. Now, what can you say about these two triangles? These two triangles are congruent. AXD triangle is congruent to BYC triangle. What's the situation? Angle, angle, and a side. In this second part, it says, show that DX is equal to by. Dx is equal to, that's the opposite angle of this. By is the opposite angle to this one. So you are asked to show dx is equal to by. So what can you say about these congruent triangles? The corresponding elements are equal. Therefore, dx side is equal to by. We need to write down the reason. Corresponding elements are equal. So that's the second part. And you are asked to show by dx is a parallelogram. Now see where's by dx? By dx. I'll connect these two lengths. So you are asked to show this is a parallelogram. So how can we say these two? This is a parallelogram. According to the congruent triangles, this length we found is equal to this length. And if we can show these two lengths are parallel, according to theorem, a pair of side parallel and equal, we can say that's a parallelogram. So we'll try to show this angle is equal to this one. If we can show this angle is equal to this angle, that means parallel. These two sides are parallel because of alternate angles are equal. We'll try to find out. We know this is 90. So what's the other angle? We can say dxa angle. Dxa angle is 90. So dxy angle is also 90 degrees. And also byx also 90 degrees. So these two are 90 degrees. And also these are alternate angles. Alternate angles. So alternate angles are equal. What can you say about the two sides? Two sides are parallel. Dx side is parallel to by side. Now we found out dx is equal to by from previous part, and also that side is parallel. So what can you say about the quadrilateral? It's a parallelogram. So therefore, by dx is a parallelogram. What's the reason? A pair of side parallel and equal. So that's the reason for by dx is a parallelogram. Look at fifth question. Two parallelograms ABPQ and ABRS are given in the figure. Prove that QPRS, we'll try to connect this. That's a parallelogram. What can you say about that? What's the quadrilateral? QPRS, quadrilateral. We know ABPQ is a parallelogram. So AB is equal to PQ. Opposite sides are equal. And also What can you say about ABRS parallelogram? AB side is equal to SR. That's also because of a parallelogram. We can write ABRS is a parallelogram and opposite sides are equal. AB is equal to PQ, AB is equal to SR. What can you say about this one? Therefore, PQ is equal to SR. PQ is equal to SR. We can see QP is parallel to SR. PQ is parallel to SR as well as PQ is equal to SR. What can you say about the quadrilateral? The quadrilateral is a parallelogram. So therefore, QPRS is a parallelogram because a pair of side equal and parallel. Question number 6. The figure illustrates a parallelogram ABCD. If AE is equal to FC, prove that EBFD is a parallelogram. EBFD. We'll try to connect EBFD. So we need to show this is a parallelogram. And we know AE is equal to FC. Now we'll take ABCD parallelogram. If it's a parallelogram, we know diagonals bisect each other. AO is equal to OC. But from this diagram, it's given AE is equal to FC. This is given and this is diagonals bisect each other. Now we'll try to subtract 1 minus 2. AO minus AE. OC minus FC. What you get? AO minus AE, you get OE or EO. OC minus FC, you are getting OF. So we found out this length is equal to this length. And also, we know that OD is equal to OB. What's the reason? I'll put another symbol like this. Because those are the BD line is the diagonal of ABCD and it's bisecting each other. So we can say this is diagonal of ABCD parallelogram. So we found out in this quadrilateral DEBF quadrilateral, EO is equal to OF as well as OD equals to OB. Diagonals bisect each other. So for a quadrilateral, if the diagonals bisect each other, then it's a parallelogram. So straight away you can write down EBFD is a parallelogram. Question number 7. In the given figure, ABCD is a parallelogram. Already marked, opposite sides are parallel. The side DA has been produced up to X such that DA is equal to AX. It's already marked. Also, DC produced and XB produced meet at Y. Prove that AXBC is a parallelogram. AXBC is a parallelogram. So this one. How can we show that it's a parallelogram? We know ABCD is a parallelogram. So this length is equal to this length. I'll use this symbol to represent that. AB is equal to DC. And also this length is equal to this one. DA is equal to BC. Opposite sides are equal. But we know DA is equal to AX. DA is also equal to AX. So what can you say about these two? Therefore, BC is equal to AX. This side, these two sides are equal. These two sides are equal means this is the opposite side of this quadrilateral AXBY, AXBC. AXBC quadrilateral these two sides BC and AX are opposite sides. And also we know that this line is parallel to this one. AX line is parallel to BC line. It's already given. So a pair of sides equal and parallel. What can you say about the quadrilateral? This quadrilateral is a parallelogram. So therefore, AXBC is a parallelogram. Because a pair of sides equal and parallel. So that's the first part. Then you are asked to show ABYC. ABYC is a parallelogram. Now we'll try to show that this is a parallelogram. ABYC. Now this one. What can you say? These two sides are parallel. If we can show this length is equal to this one, we can say it's a parallelogram. How can we say this is equal? Now look at the quadrilateral ABYC. If we can show that the opposite sides are parallel, it's a parallelogram. So what can you say about this quadrilateral. We'll take this quadrilateral ABYC quadrilateral, ABYC quadrilateral. We know that this line is parallel to this one. AB is parallel to DY. It's already given. And also this side AC and XY, what can you say? AC is parallel to XY because AXBC, we proved that that's a parallelogram. AXBC is a parallelogram. Now what can you say? Opposite sides are parallel. This side is parallel to this side and this side is parallel to this side. Opposite sides are parallel. We can say ABYC is a parallelogram. Because opposite sides are parallel. Now we'll try to prove the other part. Show that DC is equal to CY. When you take the ABCD parallelogram, ABCD parallelogram, opposite sides are equal. CD is equal to AB. And we showed that this is another parallelogram. ABYC is another parallelogram. Then opposite sides are equal. AB is equal to CY. Then what can you say about these two? AB is equal to CD as well as equal to CY. Therefore, CY is equal to CD. So, CY is equal to CD or DC. Question number 8. The diagonals of the parallelogram PQRS intersect each other at O. The points M and T lie on PO and OR respectively, and the points L and N lie on QO and OS respectively, such that PM is equal to RT and SN equals QL. So we need to draw the diagram. So we'll try to draw the diagram. The diagonals of the parallelogram PQRS. So we need to draw a parallelogram PQRS. And the diagonals intersect each other. So these two are the diagonals meet at O. So what can you say about the diagonals? We know this is a parallelogram, means these are equal. The points M and T lie on PO and OR respectively. So M and N, those are the perpendiculars. Those are not the perpendiculars, just the lengths are equal. So PO. So T somewhere here, we'll put T somewhere here. And what's the other point? T lie on PO and OR, M and T. So this is M and this is somewhere T. And the other side, points L and N. QO, there's a point L, and the other side there's a point N. So these points are there such that PM distance, so this distance is equal to RT and SN distance is equal to QL. This distance is equal to this one. You are asked to prove that MO is equal to OT. What can you say? It's not hard. We can straight away write down PQRS is a parallelogram. Because of that, we can say OP is equal to OR. Diagonals bisect each other. And also, according to the information, it's given PM is equal to TR. That's already given. When you subtract these two, what you get? 1 minus 2, you get OP minus PM is equal to OR minus TR. So what is OP minus PM? You get OM. OR minus TR, you get OT. So we can say MO is equal to OT. Then the second part, LMNT is a parallelogram. I'll take another color. LMNT. So this one, you are asked to show this is a parallelogram. From first part, we found OM is equal to OT. Now we'll take the other side. In PQRS parallelogram, OS equals OQ. Diagonals bisect each other. And also, according to the given information, we know that SN equals LQ. When you subtract these two, we can say this is L. We can say OS minus SN is ON. OQ minus LQ, you get OL. So these two lengths are equal. So diagonals, when you take MLTN or LMNT quadrilateral, what can I say? Diagonals bisect each other. OM is equal to OT and we found ON equals OL. According to the theorem, in a quadrilateral, if diagonals bisect each other, that quadrilateral is a parallelogram. So we can write this is a parallelogram. LMNT is a parallelogram. What's the reason? Diagonals bisect each other. Now, last part, MSTQ is a parallelogram. MSTQ, the other one. I'll take this color SM. Now this one you have to show SM TQ. TQ is another parallelogram. Look at carefully. When you take MQTS quadrilateral, the diagonals, now here this is the same diagonal as in the other parallelogram. MT is the common diagonal for both quadrilaterals, and we found out OM is equal to OT. If we can find out this is equal to this one, that's the other diagonal for MQTS quadrilateral. We know that's equal. OS is equal to OQ because that's the common diagonal for PQRS parallelogram. So therefore, when you take this quadrilateral, again the diagonals bisect each other. So we can say MSTQ is also a parallelogram. So what we can write for part 3? Part 3. We'll take MQTS or MSTQ quadrilateral. In that quadrilateral, OM is equal to OT. We did that in part 1. So, completed in part 1. And also we can say OS is equal to OQ. That's the diagonal of PQRS parallelogram. So that's equal. Then these are the two diagonals and bisecting each other for this quadrilateral. So therefore we can write MSTQ is a parallelogram. Because diagonals bisect each other. So therefore, MSTQ is a parallelogram. Now we know all 6 theorems related to parallelograms. Now we'll see what are the parallelograms with special properties. Rectangle is a parallelogram. We'll see what are the properties in that. Here, when you take a rectangle, opposite sides are parallel and opposite sides are equal. And it says all the vertex angles are right angles. That's the special property in this compared to a parallelogram. All these angles are 90 degrees. And the diagonals are equal in length. So this one, SQ is equal to PR. Because we know, according to Pythagoras theorem, this length squared plus this length is equal to the square root of that is equal to SQ. So same side when you take the other triangle. So what's the other property in a rectangle? The diagonals are equal, so this length is equal to this length, also equals to these two lengths. So you need to remember, if it's a rectangle, special property compared to all other parallelograms, these are 90 degrees and the diagonals bisecting each other, and the diagonals are equal. So this length is equal to this one, this length is equal to this one. That's a special property for rectangle. Now we'll take the other special property in a square. Square is also a parallelogram. What's the special property? All the sides are equal in length. All the opposite sides are equal in length. The diagonals bisect each other at right angles. So this is another special property. When you connect the two diagonals, all these angles are right angles. The angles at the vertices are bisected by the diagonals. So we know this is 90 degrees. And bisected means this is 45, 45. Here all 45, 45 degrees. So those are the special properties in a square. Angles, when you take a square, what are the special properties? All angles 90 degrees and all sides are equal. Diagonals bisect. So when you take the diagonals bisect at right angle and the angles are equal. The angles at the vertices are bisected by the diagonal. If this is 45, this is 45, all these angles bisected. And this is normal property, all diagonals are bisected each other. And now we'll take the next parallelogram, rhombus. In a rhombus is also a parallelogram. All sides are equal to each other. So all sides are equal to each other. The diagonals bisect each other at right angle. So this is all 90 degrees. And the angles at the vertices are bisected by the diagonal. So if this is x, this is also x. But this is not the same as x. Another angle, but this is also bisected. This is y, this is y. So when you take these three parallelograms, we can say take a square, and when we push one side, you can get a rhombus. Take a rectangle, push one side. When you give a push, what happens? It becomes a parallelogram. So square, all sides are equal, and rhombus is also all sides are equal and the diagonals bisect at right angle. This is also bisect at right angle, and this is x, this is x, this is y, this is y, but these are all 45 degrees. When you take a rectangle, diagonals are equal as well as all these angles are 90 degrees. But here, that's not 90 degrees. We can say this is just parallel and equal. This length is equal to this length, this is equal to this. So those are the special parallelograms you need to know. What are the special parallelograms? A rectangle, a square and a rhombus. All these three shapes are parallelograms. Now we'll look at miscellaneous exercise. It says ABCD in the figure is a parallelogram. So parallel sides are, we can see opposite sides are parallel. If DF is equal to EB, prove that AECF is a parallelogram. So we can take the one theorem, a pair of sides equal and parallel. We can say that's a parallelogram. So we'll take ABCD parallelogram. In ABCD parallelogram, we know DC is equal to AB. Opposite sides are equal. It's given DF is equal to AB. When you subtract these two, what you get? DC minus DF, AB minus EB. DC minus DF is FC. AB minus EB is AE. This length is equal to this length. And also AE is parallel to FC. A pair of sides equal and parallel. We can say that's a parallelogram. So therefore AECF is a parallelogram. Question number 2. In question number 2, it says in the triangle ABC. So we'll try to sketch the diagram. In triangle ABC, the bisector of ABC angle meets the side AC. So this angle is equal to this angle. AC at P. The straight line through A drawn parallel to BC. So this is parallel to this one, meets BP produced at D. So this point is D, such that BP is equal to PD. Prove that. In first part it says prove that BCP triangle and ADP triangles are congruent. We'll take those triangles. BCP triangle and ADP triangle. What can you say? BP is equal to PD. It's given. These two lengths are parallel. This angle is equal to this angle. We can write in this triangle BPC triangle PBC angle is equal to ADP angle because of alternate angles are equal for parallel lines. And also this angle, the vertically opposite angles are equal. This angle is same as this one. BPC angle is equal to APD angle. Vertically opposite angles. So vertically opposite angles are equal. So what can you say about the two triangles? Two triangles are congruent. ABCP triangle is congruent to ADP triangle. What's the situation? Angle, angle and a side. That's the first part. Show that ABCD is a rhombus. ABCD is a rhombus. So what's the property, special property in a rhombus? All sides are equal. So what can you say about the sides? So when you take ABCD quadrilateral, we know that BP is equal to PD. That's given information, as well as PC is equal to AP. Why? PC is equal to AP. That's the, when you take PC and AP, those are the corresponding elements of the congruent triangle. So when you take the congruent triangles, this is opposite to this side. So this side is equal to opposite to this side. We can write AP is equal to PC, corresponding elements of two triangles are equal. Now, in this quadrilateral, the diagonals bisect each other. Therefore, ABCD is a parallelogram. The reason is diagonals bisect each other. Now what's the third part? If AC is 18, AC is 18 and BD is 24. So if this is 24, we can write this is 12, this length is 12 and this length is 12. Other one? 18. The full length is 18 means this is 9 and this is 9. Find the length of AB. Now we found out ABCD is a parallelogram, but in the question it says show that ABCD is a rhombus. So what's the special property in a rhombus? All sides are equal. If we can show all sides are equal in this parallelogram, that means it's a rhombus. Now look at carefully in this diagram. ABD triangle. When you take ABD triangle, this angle is equal to this angle. So what is that triangle? Isosceles triangle. So ABD is an isosceles triangle then AB is equal to AD. AB and AD, this length is same as this length. So adjacent sides are equal in that parallelogram. Adjacent sides are equal means it is a rhombus. So we can say ABCD is a special kind of parallelogram. ABCD is a rhombus. Now we found out this is a rhombus. So what's the next part? Next part says if AC is 18 and BD is 24, find the length of AB. You are asked to find one side of a rhombus. If this is 18, AC, this is 9 and this is 9. This is 24, this is 12 and 12. What can you say about if this is a rhombus? What's the property? The diagonals bisect at 90 degrees. So if you take one of the triangle, that's a right angle triangle. ABP angle, ABP. You take ABP triangle. This distance is 9. This one is 12. Easily using Pythagoras theorem, you can find the length AB. We'll use Pythagoras theorem. AB squared is equal to AB squared is equal to sum of squares of the other two sides. 9 squared is 81. 12 squared is 144. When you add it together, you get 225. What's the square root of 225? You get 15 plus or minus 15. But this is about length. So the length is plus 15. What's the unit? This is in centimeters. So 15 centimeters is the length of AB. Question number 3. In the triangle ABC, the midpoints of the sides AB and AC are respectively X and Y. We'll draw the triangle. The triangle ABC, the midpoints of the sides AB and AC are X and Y. So this is X, this is Y. So I'll mark this distance is equal to this one. This length is equal to this length. The straight line drawn through C parallel to AB. Parallel to AB meets XY produced at C. At Z. Prove that AXY triangle is congruent to CYZ triangle. So when you take AXY triangle and CYZ triangle, what can you say about those two triangles? This length is equal to this length already given. AY is equal to YC because of midpoint. And also these two lines are parallel. So this angle is equal to this angle. Alternate angles are equal. XAY angle is equal to YCZ angle. Alternate angles are equal. And also this angle is equal to this one. Vertically opposite angles. AYX angle is equal to ZYC angle. Vertically opposite angles are equal. Now we can say straight away these two triangles are congruent. Therefore, AXY triangle is congruent to CYZ triangle. What's the situation? Angle, angle and a side. So those two triangles are congruent. Now, the second part it says show that BCZX is a parallelogram. How can we show that's a parallelogram? We know that this side is equal to this side. Why? The corresponding elements are equal. AX is equal to CZ, corresponding elements of the two triangles. Corresponding elements are equal. But we know AX is equal to BX because of the midpoint. So what can you say about this? AX is equal to CZ, AX is equal to BX. Therefore, CZ is equal to BX. So this length is equal to this length. And also these two are parallel. And also we know BX line is parallel to ZZ. So these two are parallel and equal. A pair of sides is equal and parallel. What can you say about this quadrilateral? So in this quadrilateral, that means BCZX, BCZX quadrilateral is a parallelogram. And what's the reason? A pair of sides is equal and parallel. So we showed that BCZX is a parallelogram. Now look at question number 4. In the parallelogram ABCD, the midpoint the midpoints of sides AB, BC, CD and AD are PQRS respectively. So we can mark P, Q, R. These two lengths are equal because opposite sides are equal, and S. Prove that ASP triangle and CQR triangles are congruent. So we'll take those triangles, ASP triangle and CQR triangle. We know that AS is equal to CQ and AP is equal to CR because all these PQRs are midpoints. And also ABCD is a parallelogram. Opposite sides are equal. And this angle is equal to this angle because opposite angles in a parallelogram are equal. SAP angle is equal to RCQ angle. Opposite angles are equal in ABCD parallelogram. Now, what can you say about these two triangles? These two triangles are congruent. ASP triangle is congruent to CQR triangle. What's the situation? Two sides and included angle. Two sides and included angle. Side angle, side. So here we can write this is also included angle. So side angle, side. Side angle, side. So the two triangles are congruent. And the second part, PQRS is a parallelogram. Now, to show that it's a parallelogram, we can show these two lengths are equal. Why? The corresponding elements are equal. And also, similarly, when you take these two triangles, we can show that this side is equal to this side. Opposite sides are equal means PQRS is a parallelogram. So we'll try to do that. Part 2. We can write SP is equal to RQ. Corresponding elements are equal. Corresponding elements are equal because we proved that ASP triangle and CQR triangles are congruent. Similarly, when you take SDR triangle and PBQ triangles, we can show these two are congruent. We'll do that. DR is equal to PB. SD is equal to BQ because of midpoints. And this angle is equal to this angle. D angle is equal to B angle according to two sides and included angle, these two triangles are congruent. Side angle side. So therefore, the corresponding elements SR is equal to PQ. Now, we found out this side is equal to this side is equal to this side, this one is equal to this one. Opposite sides are equal in SPQR quadrilateral. Therefore, this is a parallelogram. Therefore, PQRS is a parallelogram. The reason is SR is equal to PQ, PS is equal to, we showed here, PS is equal to RQ. Opposite sides are equal. Here we showed that PQR is a parallelogram. In this chapter, we covered all theorems related to parallelograms. Altogether, there are 6 theorems. Try to remember all these theorems and apply in parallelograms.